All right, so this next one, it says, during a summer thunderstorm, the temperature drops and then rises again. The rate of change of the temperature during the hour and a half after the storm began is given by this function, T of H, where H is the number of hours since the storm began. So a graph of T is shown in the figure below. All right, so we get the graph. What we're supposed to do is locate the input value between H is 0 and 1.5 at which it crosses the horizontal axis. So we're supposed to find that A. Then we're supposed to estimate between 0 and A the T of H dH and interpret result. Then between the A and 1.5, and then between 0 and 1.5. So all of those things we're supposed to do. All right, so things to do. First, find that A. So let's use our calculator. And because it takes so long, I typed it in already. And so that's our graph. So all we have to do is we have to say second trace and find our 0. And so we'll say our left bound is about right there. Our right bound goes up to positive there. And so we get, that is our intercept. All right, so let's go back and write that down. So this is going to be 0.9071 comma 0. And we'll just go to 4 decimal places. All right. Next thing, we have to think about how many, let's see, hour and a half, what is the number, locate the value between graph, estimate between 0 and 9, interpret the 0. All right, so basically we have to think about each square. If we split this into 9 squares, and I think that's going to be easiest because if we think about that, that's 0.9071. So if we take 0.9071, divide it into 9 squares, that gives us a roughly 0.1 unit per square. Okay, so we're going to cut it into 9 squares. And again, I just did that because that's divisible by 9. You could do other number of squares, but I think that one is going to be kind of a key thing to do, is do it by 9. So we're going to go by 0.1. So then what kind of should we use? I think midpoint is going to be the best because we've shown that midpoint is the best value. So I wrote that we're doing midpoint. We're doing it, again, by that 0.9071 divided by 9 is 0.1. And so 0.1 divided by 2, because remember, we're going from 0 to 1 and we're doing midpoint, that's going to be 0.05. And then we have another 0.1 for that, 0.15, 0.25, 0.35, 0.45, 0.55, 0.65, 0.75, and 0.85, because then if we go beyond that, we're beyond the 0.9. All right, now we have to figure out our heights. And so that means we go back to our calculator and we write all these down. And so we have to basically do our second trace again and a value. And we start and go down our list. So we're going to do 0.05. And we get negative 9.2876. And then we do our 0.15. And we get negative 78267. Okay. And then we get 0.25. And we get negative 65903. And then we get a 0.35, negative 5.5214. And then we get a 0.45, negative 45631, and negative 0.55, negative 3.6582, and then a 0.65, negative 27498, negative 75, negative 1.7809, and then 0.85, negative 0.69456. Okay, so what we've done is we found the area down here, okay, the negative area. So let's go back and write all these in. So negative, that was 9.2876, negative 7.8267, negative 6.5903, negative 5.5214, negative 4.5631, negative 3.6582, negative 2.7498, negative 1.7809. And finally a negative 0.6946. Now, what was our unit width? Well, that was 0.1. So we have to take 0.1 times all these, or basically move all the decimals over, one left. So 0.92876, negative 0.78267, negative 0.65503, negative 0.55214, negative 0.45631, negative 0.36582, negative 0.27498, and negative 0.17809, and negative 0.06546. And now what have we been doing? Well, we're going to take the sum of all of these areas. So if we do that, which I've calculated 4.26726. So that's our area on the bottom part here. So we've just calculated this area, okay? Now what we have to do is calculate this area, okay? And so what does that mean? Now we have to start at where? Well, if we start at the 0.9 and we add, what do we go by? We went by half of that, so 0.05. So that's going to be 0.95. And then we go by our units of 1. So it's going to be 1.05, 1.15, 1.25, 1.35, 1.45. And we stop because it stops at 1.5, so we can't go above that. So we stop now. And so we don't have as much to do on this side, luckily. And so again, we're going to go back over here. And now we start at 0.95. So it's 0.5663. Then we went to 1.05. 2.0587, okay, 1.15, 3.8396, and then 1.225, 5.9659, and 1.35, 8.498, 8.4948, okay, get that right, and 1.45. 11.4832. All right, so now we've got all those, so let's go write them in. And so 0.5663, 2.0587, 3.8396, 5.9659, 8.4948, and our 11.4832. All right, so again, we're taking it times 0.1 because our width is 0.1. So if we do that, we're just moving decimal places. So 0.05663, 0.20587, 0.38396, 0.59659, 0.84948, and 1.14832. And again, we're going to take the sum of the areas, we add all those together, and we get 3.24085. All right, so what does that tell us? All right, so from basically 0 up to this point in time. Now, we should probably figure out what that point in time is. So let's go back to our calculator. And let's quit that. And so we had 0.9071, and it's per hour. So if we take that times 60, we get 54.4 minutes. So if we round that, that's going to be 54 minutes. Okay. Now, when we take, if we take basically 1.5 hours, which is going to be 90 minutes minus 54 minutes, we get 36 minutes. All right, so that gives us that part. So now this is going to be, this piece here is 54 minutes, and this piece here we said is 36 minutes. All right, so that helps, and we had to know that intersection point to be able to do that. So what can we say? because we're supposed to interpret all these results. We have multiple things to do here. Let's first do the this one. So during the first, we said that was 54 minutes. After the thunderstorm started, what happened? Well, the temperature, and it dropped by how much? Well, it dropped by, well, let's just round this to 1 decimal place, because how many do we have over here? I guess we have at the most, we have 2 decimal places. So maybe we could do 2 decimal places by, let's say 4.27 degrees, and it was in Fahrenheit. Okay, so that one's what we have there. Now what? All right, so now we can say after the first 54 minutes, because this is after 0, so it's during the first 54. After the first 54 minutes, the temperature started to rise, it looks like. And in the next 36 minutes, rose 3.24 degrees Fahrenheit, okay? And so now we're supposed to estimate between 0 and our 1.5 what the actual temperature went up by, okay? So what we're gonna have to do is we're gonna have to kind of calculate that one. And so let's start there, and when we get to that, so with that one, what we have to do is we have to take our difference here. So we're going to take a minus 4.27 plus 3.24 and 24. That's going to give us a negative 1.03 degrees Fahrenheit. So what we can say is 1.5 hours after the thunderstorm began, the temperature was 1.03 degrees Fahrenheit lower than the start of the storm. Okay. All right, so I think that covers all of our questions. All right, so let's pause there and come back for more.